Hello and welcome back to the show. My name is Relevant. This is Do All the Things. On today's episode, further cycling, the perpetual violence. The Jet City head is going under the knife once again. Today, we start sorting out the effects loop issues once and for all, but I need to start rebuilding the switching metrics on this thing so that it can accommodate a dual foot switch to switch the effects loop on and off. So, stay tuned. If you've been following the comedy, in a previous episode, I deleted the effects loop out of this thing. The crappy freaking Soldano effects loop that it blows. Yeah, and you know what? It's a better sounding amp without that weak link in place, where we pretty much run the cathode follower normally right into the tone stack, getting rid of all this crap right here. Yeah, it definitely blah, blah, blah. It's better. But you know what? I want to have this amp to have an effects loop. Was that even a proper sentence? So for the last little while, I've been designing a little something something special based on a little something something famous. Does this circuit look familiar to you, bud? Yeah, that's the effects loop from the good old Friedman BE series of amplifiers. Supposedly the zero loss super transparent effects loop. And it's based on LND 150 MOSFETs. Those MOSFETs I played with before that can pretty much substitute preamp tubes. So it's kind of like a tube effects loop, except with MOSFETs. And I might have mentioned it before, like tubes are great for generating distortion textures and that tone. But when you just need to take a signal, amplify it, buffer it, and then recover it, and then add it into a signal chain with 100% transparency, I don't feel that tubes has a lot to offer. That's where solid state can be a tool in our kit. Now what's great is because it uses those high voltage MOSFETs, it means we can run it off the existing power supply. We don't need any special 15 volt power supply to run op amps. Now this particular design uses a relay because it's foot switchable. Now the way they insert this effects loop, they do it post master volume pre-phase inverter. So yeah, you might want to turn that on and off sometimes. Now this amp already has a switching metrics, a very crude one just for the channel switching. And I have this foot switch that I rigged up with the LED. And so far, it works fine. At least now it does. In a previous episode, when I changed out the power transformer on this, because you remember, this thing had a blowed power transformer, it had a second 6 volt secondary to run the foot switching circuit because the way it's designed, you couldn't really run it off the heaters. Now, it was only 6 volt, whereas the amp originally wanted a 12 volt. And I actually found in practice, it wasn't working properly. It was ghosting on me. You'd be playing the amp and all of a sudden it would start to sound funny. And I couldn't figure out what it was until at one point I went to switch channels while it was sounding funny. It sounded good again. It seems that there wasn't enough voltage to hold the contacts in the crunch channel, and maybe they would start to pull apart, and operating the LED let just enough current through to start the relay starting to energize and engage, and that would screw up playing on the overdrive channel. So what I had to do was I had to use the same trickery that I've used all throughout this amp. Bam! That right there is another voltage doubler, coming up with upwards of 18 volts. And then once it goes through the circuit and the dropping systems that that switching circuit has, it puts about 13 volts to those relays. And now they're working A-OK. So yeah, this transformer is literally half all the rated voltages. I have a voltage doubler on the main supply, a voltage doubler on the bias supply, and now a voltage doubler on the switching supply. The only thing I haven't had to double was the heater. So for switching metrics, something I've been working on a while, a little pet project, trying to come up with a very reliable and simple foot switch detection circuit, if you will, so that the foot switch in ways would be isolated from the actual switching circuit, even though that's semi-redundant. But the design of this makes it so that I can pretty much throw it into any amplifier I want. In a previous episode, I did some foot switching mods to an old custom reverb. In retrospect, that design sucks. I kind of want to redo it. This design's awesome. And this is the gist of it right here. Now I have up here just kind of showing off the voltage doubler supply for the heaters, putting out 17.4 roughly. All the math accommodates between 17 to 15 volts for this particular design. You would change the values of the resistors to accommodate different voltages, but it's all pretty simple. Now, typically in the foot switch, we have an LED and a 470 ohm resistor in series so that whatever is powering this circuit can run the LED, and then when you flick the switch, it just shorts out the LED, completely grounding out whatever this circuit is, and that's what triggers it to turn on. So we have a double op amp here, an LM393, or in my case, specifically an AS393. It was basically the cheapest voltage comparator that I could find that would do the job, and it behaves funny. It doesn't behave like other op amps. We have our typical arrangement where we have a voltage divider creating voltage reference going into the inverting input of the op amp, and then the non-inverting detects what the pedal is doing. The junction here between the pedal and that 1.2K resistor, that's the positive voltage rail, is going to be around 5 volts. And then the idea with the voltage reference divider here is to create a voltage reference lower than 5 volts. So when the LED is on, the op amp is seeing higher than voltage reference, and then when you flick the switch, it sees 0 volts, which is going to be under voltage reference, and that's what triggers the op amp to do what it does. So basically, the op amp is just looking at what you're doing with the switch, and then it'll go and turn stuff on and off for you. The purpose here is half so it can work with generic foot switches, and generic foot switches that have LEDs will have that 470 ohm in there. Now making this is pretty simple. We got 470 here, so the bottom of our voltage reference is 470. Then we just have to make the top of our voltage reference bigger than whatever resistor sets our voltage for the foot switch to run the LEDs properly. Basically, this value is determined when added to this value gives you about the right amount of current you want to run that LED with whatever given voltage. 1.2K plus 470 is about 1.67K, which is going to give us, 8 to 10 milliamps. The voltage in this circuit floats between 17 to 15 volts, but everything changes proportionally, so it all still works normally. So the basic functionality is that the op amp floats high, which is a generalization right now, not totally accurate. You see, the LM393 is not bipolar like other op amps. If we look at the simplified schematic for one half of the LM393, you see the output is just an NPN transistor to ground. So there's no high output. Normally, a lot of op amps work in opposition to this, and when they see the voltage, junction voltage higher than the voltage reference, they turn on and put out a positive voltage. This doesn't do that. The LM393 does nothing when it sees junction over reference. However, when the junction voltage drops below reference, that's when it turns on and it gives you negative voltage out the output. So when we click on the switch and the non-inverting input sees 0 volts under voltage reference, then it sends negative voltage out of its output, which we can use to fire or control something on this end. So this circuit might not work properly with other normal op amps. I actually tested it with like the LM072, and I did not get the functionality I wanted. I could manipulate it too, but then stuff starts getting a little bit tricky. The LM393 with its extreme simplicity and just single functionality makes doing this a breeze. So as you can see here, I'm using something called an LLA108. That is a solid state relay in that same DIP8 package. And it's basically an optocoupler. You got a LED on one side firing a pair of MOSFETs. It can pass AC signals in ways you could use the LLA108 to directly switch stuff going on in the amp if you have functions where you just ground out the circuit you don't want to work. In theory, it can pass audio signal. I've tested it, passing audio signals as low as 100 millivolts consistent with guitar, and exactly what went in came out. However, I actually asked the manufacturer about this guy, and they say it's probably only good to about 3 kilohertz before its internal capacitance is going to start throttling off that high end. So I don't know if I'd want to use it to actually switch audio signal. That's a test that I need to do in the future, because this thing's so friggin' easy to work with, even compared to a conventional relay. It would be wonderful if I could use it to route audio. So 4.7K biases these LEDs because they only need somewhere like 5 to 2 milliamps to actually fire. I think this spec is going to give us between 3 and 4.7K on a 18 to 15 volt rail. And then boom, whatever we want to switch, we just hook here. The LLA108 with an on resistance of typically 4 ohms, so it's going to be very transparent, is rated to host 600 milliamps of current, which is more than enough to switch a relay or many other kinds of relays. Debatably, some transistors have more capacity than it, so your application may vary, but at the end of the day, this circuit drives whatever you want with a low signal. Seen here are a couple PNP transistors. I kind of of just threw them in there because pretty much if I hook those up to the output of the op amp, then they'll switch too. So, you know, if you're a corporation and want to cut your corners right down, you could just use a couple PNPs. I actually tested them with no buffering whatsoever. No resistor linking this thing, no pull down resistor to turn them off when they should be off, and it worked fine. It switched this circuit. Because I want a proof of concept this the way I do, I'm going to be using the solid state relay. Debatably, it's a more expensive part. You're going to pay about $3 to $4 for one of those. Plus you need to add a couple of resistors at, 79 cents for 10. So high roller. PNPs, they're what? 40, 50 cents each. Just chuck a couple of them in there. But transistors have flaked out on me in some of my crude arse designs here. At the end of the day, we have basically this functionality. This simulates the inside of the foot switch. We have the 470 ohm resistor. There's our 1.2K. We click on the foot switch and boom, the op amp drives the relay. The relay fires whatever load you want on it. Beep boop beep boop beep pop 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 beep 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 pop 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 beep beep pop 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 pop. And if I pan out, you can see right now I'm powering this off the foot switch supply. So I've never been really good with solid state technology. This is something I've been more recently researching so I can learn how to better control my amp designs. And I'm proud to say this is one of the first circuits of this type that I've designed completely with math, just crunching numbers on paper. And then when I went to build it, it just worked perfectly. So we need to build this into something that will go into here. So this is the layout that I've come up with. We got ourselves our jack. We have a common going out to selector switches on the amp itself, and then they return here onto the fingers. And the actual jack contacts are gonna go onto the op amp right there. There's our voltage reference. There's our junction. The 470, remember, is in the foot switch. And then we have our solid state relay right there. Common ground. Those are the outputs to drive the relays. Foot switch out is going to connect to the foot switch connection on the amp chassis, and then this is going to connect to the relay on the effects loop board. Now the relay on the effects loop board is going to be a 12 volt relay. That's going to be the plus for the relay set by this resistor here. I'm not sure if a 220 is what I need. I actually need to experiment on that here right now. So right now we're seeing how much volts. We're at 17 volts right now. And when I click this on, so yeah, with this relay fired, we're gonna say 17.5 volts. And the relay works at about 12 milliamps. So if we do the math, we have 17.5 volts to work with. Gotta take away the 12 volts the relay works at, that's 5.5 volts. We divide that by the current of the relay, which is something like 11.6 milliamps or 0.0117. And it wants perfect. It wants just straight up a 470 ohm resistor. Well, that's good, bud. That's good. That's gonna work for us. Oh, so that means if we 470 this supply here, and then we get the relay we're going to be using, a little Panasonic TX2 signal switching relay. One side's positive and one side's negative. It has a bias. We'll actually take the 470, we'll put it on the positive rail, much in the same way it's done in the schematic. We'll connect the positive to here. If we attach negative, we must have it backwards. I don't see an actual positive marking on this thing. There it goes. She clicky clicky. She clicky clicky. There's a chance that we can run this directly off the op amp actually. I think the op amp's good to 50 milliamps. Yeah. I'm not going to though. All right, we'll just splice in the relay. Connect that, and clicky clicky. All right, so let's energize that relay, and what do we have? 12.2 volts, perfect. All right, let's update the spec on this pupper right here to 470. Boom, save. Now let's build it. All right, so here's what we have here. I'm gonna refer quickly to the part number. ACJSMHOM is this particular jack. Non-isolated. It's got like these nice serrations built right in. Kind of like having a built-in lock washer. The design of this amp, at no point does the circuit ground out to the chassis other than on the foot switch jack itself. That's not it, it's over here. So I got this guy so that once we do this, it's gonna ground to the chassis. None of the circuits depend on chassis ground to work. You could use an isolated jack, but it is good form to ground out a part of any circuit. And then as you can see, I just stuck it on a perf board. Now, the pinout of these jacks is never matching up with the 2.5 mil format of a typical perf board. I also had to trim off the edge so that this could go matte flush. But this should make for a nice module. And by the way, this is the relay, TX2 12 volt Panasonic switching relay. Now we refer to our layout. Let's start building on it, bud. I advise you to have a vise. All right, 'tis what it looks like, yeah. Doesn't show up very contrasty on the camera, considering it's all very shiny and green. But you gotta make note of a few little design situations. Like here, these holes, I had to drill out. These are double-sided pads. That means whatever touches them on one side is going to transfer over to the other side. So if you have a crossbar like this, you got to make sure any intersections are drilled out. Like right here, that is probably going to touch that pad. So if that wasn't drilled out, we'd have a short here. And that happened here too. But otherwise, everything else is pretty straightforward. I forgot, you need a flywheel diode on a relay. So kind of threw that into here on the relay side. Grounds out. That also made the bus that connects the connect the SSRs to the ground bus. We're pretty much ready for wires now. And we're going to need all the color codes, sir. All of them. Okay, we need to declutter this desk. There's crap everywhere, bud. Gotta see if we can't get this spliced in there now. Alright, so the generator we're working on is right over here, sir. We have Footswitch, that blue connector, and then here is Footswitch ground, which is an established ground bus for the entire Footswitch power supply. Oh, there's crap and garbage in that hole. I just have to remove this existing jack. This one's decent quality. And then this thing is gonna go in here some way, somehow. Just kind of like, you know, one of these. I plan on putting it kind of sideways. But I guess it could go in just about any orientation. It could go sit like that if we want and look a bit prettier. Oh, look at this thing. Almost, hey! Oh, look at this thing. Almost, hey! There's a little bit of juice in this amp, bud. Woohoo! Okay, what did I touch? R44. Those are power supply caps. Be careful, buds. Be careful. We don't need this long boy. Let's give it the snip. So where was I? Okay, yeah, that's gonna sit there quite nicely, I think. And some of these junctions aren't gonna be very long. This jack sticks out quite a bit on this side. Okay, you gotta worry about those ground points on the other side that don't have support yet. So, black and blue are very key figures in this society. But red, well, we're not getting anywhere without red. Red has to go down. Red's our main power. Kind of want to get it to do one of these things. And it's going to run all along the amp over to here. Black has to go to FSG, and blue has to go to FS. They do not need to be very long. We'll give us some slack so that we can manipulate this thing after it's installed. Alright, bud. A little bit of crisscross action. Part of my plan is to add a button or something to the front of this amp so I can switch channels without the foot switch. Kind of annoying, always needing the foot switch for this amp. All right, that's on there. We might as well put in the crystals next. Where are the crystals? Our LLA 108 goes into this socket, and our AS 393PE1 goes into this socket. It's like a 50-cent part. Haha, yeah. Now I just have to get power to this. That happens over here on the other side somewhere. This looks about roughly the right length right here. Just need to fish it underneath all these, everything. One of these days I need to go through this amp with a bunch of zip ties and fix on all this wiring. This haywire wiring. This hay wiring. And then the plan for this guy is that the holes on the PCB here are pretty gaping. So if I pull this existing red wire coming off the voltage doubler, I'm gonna have a nice big hole to work with. I just put our one wire through here and our other wire through here and solder those together, and we should have power to our module now. There we go! Now let's test. Theoretically, if I just go in here now, short out these pupper contacts. Oh, she switches. She switches. course, it works exactly like designed. So now if we grab ourselves a generic foot switch like this crate unit, TRS cable, plug into here, other side of TRS, plug into here. Oh, look, we got lights. Now we haven't got the second relay hooked up, so we're not gonna see anything there, but either this isn't working or the thing's so freaking loud, I can't hear it. Yeah, clicking on this switch is just so loud I can't hear it. She's switching, bud. She's switching, and we have LED indication to let us know what's going on. And if we can go here, that's gonna work. Now, if we want, we can still use the original single foot switch. It has a 1K resistor in it, but it should still work. Now, it's gonna automatically ground out the second circuit, or the FX relay. But the way I plan on wiring this, I'm gonna have a push-pull pot for the effects loop level. And if I pull on it, it's gonna bypass the foot switch. So we can use a mono foot switch, manually control the effects loop, and then just have bomb. Even with a 1K resistor, it works good. So I don't have to modify this thing. All right. I'm gonna have to remanage these wires to fit in the actual effects loop board. Everything's gonna fit. It's just a case, yeah. So I think that's good for now. Stay tuned for the next episode when I'm going to be actually building the effects loop module, and then we're going to have this all complete. Yes. We're going to have to do some drilling, get some pots mounted, figure out what we're doing for pots. I think it's time for me to break for dinner. Yeah. Stay tuned, buds. Yeah. 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 Ha 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 ha. Switching. Oh, come on, man.